Welcome back to the takeoff training, and in this video we're going to show you how to check for metal using the BIM model. So specifically we're going to show you how to use the shop drawings, checking the details to ensure the correct parts are there, and also using the shop drawings to check for dimensional, using the dimensions given in the elevation and the details, and then using that to confirm the cut sizes of our extrusions. Okay, so let's begin. Okay, so by now you should have already UPD'd all your units that we've picked out, so essentially 5 units. Let's start with the first one, which is your unit 129. So what you want to do is open up your Bluebeam session with the shop drawings open as well as the key sheet. So we're going to identify where the unit stands or where it's located. So in this case it's on elevation 12A on sheet 205. It's the intermediate unit. So unit 129 is right here. So let's go over to your shop drawings. So it's these 2 units right here. So what I normally like to do first is just kind of look at the details, right? Let's confirm it's using the right details. So we can see that on the sill detail is 1 on 505, right? And then 1B on 505. So let's click into that first and see what's the difference. So there doesn't seem to be much of a difference, maybe an added steel plate. Anchoring is all the same. The sill, if they're going to cut down over here, there's nothing to do with the sill member, so it's safe to say that it's the same sill member. So let's go over to 1A on 505A. So it looks like 1A condition is just the perimeter, so it doesn't change anything. So the reason why I'm looking at this first is to just get myself accustomed to how the unit will look like, right? So your detail over here for the verticals is 2 on 555, 2 on 551. So nothing special, just your typical invisible vertical detail. So let's move this over to your left side. So for you it should be a little easier because you have 2 screens. So for the sake of this recording I had to move back and forth. So if you take a look at the detail bubble, right, it's calling out 1 on 505A at the head, right? The shop drawings show 1A, but 1A only shows the difference between 1A and 1 is just the perimeter, so we can go ahead and just say this should be fine. 1 on 505 is at the bottom. Difference between 1 and 1B, it's relatively the same. There's really nothing, so we can go ahead and say confirm that 1 on 505 is an okay detail to reference. And also the verticals are 2 on 551. Okay, so we have confirmed that the detail bubbles we're working with is okay. So we'll just go with that. So right now we're going to check if the correct parts are being produced, right? So let's go into the model space first. So I like to just check the horizontals first. So if you remember the command VPE, brings you to the side. It gives you a nice view of how our horizontals are usually cut. This is laying flat. If you want it to make it look like it's resembling our details, you can kind of rotate it over here in AutoCAD. So now it's standing vertically. So it looks more like your detail. So I'm not going to show the shop drawing side. You should already have the shop drawings open on one side, so I'm just going to guide you through it. So on your shop drawing side, the screen, you should click on the sill detail, which is 1B on 505. And in here, let's look at the extrusions that are being produced, right? That ties with your sill member detail. So you can see that the W751156 is your sill member. So it's right there, very apparent. So 1156. Okay, what else do we have? We have these little setting chairs. This is W75 1402, which is shown on your shop drawings. You should see it's towards the exterior of the building. You should see it as 6-inch long at quarter points. So 6-inch long. Okay. Okay. So is there anything else? Don't think so. In terms of extrusion, so we can confirm that your sill member is taken off correctly, right? It's at least the part is there. Okay, so we can confirm that. We can come back and confirm the size later. So let's move over to the head. Okay, so let's highlight the head. Okay, so let's go over to your shop drawings. So your head detail is 1A on 505A. So click into that. So you see here, our main body is the W75 3165. It's called out there towards the back of the detail. Towards the front, we have a trim. It's part W75 3513. Okay. So those are confirmed. We're good. And you may look at, okay, W75 3608, which is your mini Mac, and then you have your other filler piece. You may wonder why is it not shown on a unit, and that's because this is a unit. Those parts that we just mentioned just now are few use parts. Okay, so few use parts belong on key sheets, elevation key sheets, while anything that you want the shop to assemble shows on our unit assembly drawing. Okay. So with that said, this is the head is good. Okay, so let's check our verticals now. So the other command to make it quicker is VPF, which brings you to the bottom. Okay, the bottom view. Okay, so just remember that. So let's go over to your shop drawings. Go to detail 551. Okay, so let's highlight the left side of your unit, which is your female. So your female part is W75 5263. All right, compared to your shop drawings. Remember, this is the left side of your unit. Okay, so that's confirmed. That's good. And now the right side of your unit, which is your male side, is W75 5263. Right. So then the detail, your male is W75 5262. Excuse me, it's W75 5262. Okay. So with that said, this unit has all the right parts built into it. Okay. Now you can kind of play like a caveat, right? Kind of going back to the head. If for some reason your filler and your mini Mac needs to be on a unit, then you need to show those parts here. But just to kind of give you another idea of how those two worlds work between units and few use. Okay. And again, we're focusing only on metal, extrusions, angles, and whatnot. When you see parts like fasteners, they're not going to show in the BIM model. Gaskets, normally we don't show those as well. All right. So it's not going to be extruded on to the BIM. Okay. So next we're going to move on to how to use the dimensions, right, shown on our unit assembly drawing and comparing it to the shop drawings, right, to check for metal. Okay. So with this one, I'm going to be using the shop drawings, jumping in back and forth, so you're going to have to bear with me. So to start, let's confirm the dimensions shown on our unit assembly drawing. So go back to paper space. Okay, so while in paper space, you can see there's dimensions here, right? You'll see a overall vertical dimension of 117, and then you have the 2.5, which is your profile of your horizontal, and then you have your daylight here. Okay, and then horizontally you'll have also your daylight, your vertical profile, not necessarily vertical profile, but then profile in relation to how the Revit family is drawn, right? And then your 60-inch, your overall dimension, and that dimension is usually your overall dimension shown here is usually your dimension point to dimension point, or I like to refer to also as your Revit insertion point for the families, right? So for now, we're going to start with confirming the vertical dimensions, right? So your 2.5s, your 1 and 112, and then your 2.5 on the head, and then the 117 overall. Okay. So if you take a look, I'm going to actually bring over the shop drawings here. So if you take a look at this sill detail, right, the profile here is shown 2.5. So now remember what I said, right? It's to the Revit insertion point of the family, right? So for the sill family, Revit family, they're usually 7/16 below bottom of this sill member, right? Or I like to call it bottom of vertical. Okay. So in this case, it's 7/16 below that, so it's over here, which is why you see the program drawing the profile as 2.5. Okay, so we're confirming that. So it's 2.5. Okay. So let's go back to this guy. So let's confirm the daylight now. Okay, so let's go back. The daylight is 112. So let's go to your elevation. Okay, so this one you may want to pull up a calculator. It'll help a lot. Okay, so pause for a sec here. Okay, so now that we have pulled up the calculator, we can start calculating the daylight of our opening, our unit assembly drawing. Okay, confirm that 112. Okay, so here we have, we're going to be using specifically this dimension right here, your DP to DP. Okay, so now, so with that, it's going to be 119 inches, or you can just do 9 foot, so 9 times 12 is 108, and then you can plus the 11. So 119. Okay. So next we will, oh, sorry, that's not the shop drawings. Same thing. So next we'll have to open the sill detail. So with the sill detail, remember the DP is right here, your dim point. So it's going all the way to the bottom to the floor. So we want to get to over here. It's your daylight. So just to give you a visual, this is your DP. And we're trying to get to over here, just in case you don't know. Okay, so you want to subtract 3/4. Then you subtract 2.5. Okay. Let's do that again. Okay. Okay, so we go back to the elevation, do the same for the head. Pull up the calculator. So here you have your DP, we have up here, and then you're trying to get to where the daylight is, right? So you want to deduct 1.25, it's your joint, then deduct 2.5. So 112. So let's open up your unit assembly drawing again and confirm 112. So now we have confirmed your daylight, your profiles. And with that, basically your overall should also be correct. Okay. So next we're going to confirm the horizontal. Okay. So the horizontal is the same kind of theory. Just open up your, instead open up your vertical details, right? So let's go back to your elevation. So these are units. So from DP, so we can do center line to center line, which is your DP to DP, is 5 foot. So 5 times 12 is 60 inches. This one should be a lot easier. So again, your dim point is right here in the center. So that's where your tagline is inserted. That's where your Revit insertion point is for your tagline. Okay. Okay, so we know the profile is 2 3/4. Right. So keep 60 there first. Right. So we know the profile is 2 3/4. So you would deduct half of that. Right. On one side. So you can do minus 1.375, so that's 1 3/8 on one side, and then you do another 1 3/8 on the other side to bring in daylight. Or you can just deduct 2 3/4, right? So this is your daylight opening for your horizontals, which is 57 1/4. Okay. So let's go check 57 1/4. So now that you confirmed all these numbers, right? You can go into your model space and highlight these parts. So what I like to do is kind of going off of the horizontal first, since we last checked that one, right? Just highlight the sill member. Your sill member is stopping daylight. Remember that it doesn't go past your vertical. So 57 1/4 is correct, right? And then your head is also 57 1/4. Okay. And then your trim, the logic there is you want a 1/4 inch joint in between the units. So then you're going to be deducting 1/8 inch on the left, 1/8 inch on the right, to be a 1/4 inch in total. So remember, your overall dimension is 60 inches. So 60 minus 1/4 is 59 3/4. 59 3/4. So the trim is confirmed, your head is confirmed, and your sill member is confirmed. Okay. So now let's go into and check your vertical. Okay. So your vertical, all right, let's go back to, okay. So your vertical is rather simple. You can use the overall dimension again. So 119. Right. 119. Open up the sill detail. Now you need to know where your vertical would stop. Right. So our W75 system, our vertical just stops in line with this bottom of the sill member here. Okay. So luckily we have these dimensions to plug in to help us find the bottom of vert. So just subtract 3/4, then subtract 7/16 for this number right here to get to that point. Minus 0.4375. So now we got to the bottom of vertical, right? There's 117 13/16. Okay. So now we need to compute the top of vertical. All right. So go back to your animation. Click the head detail. Okay. So now again we're over here. So you want to deduct 1.25, at least get the joint out of the way. And for here you would stop the top of vertical right at the top of the head. So right here. Okay, so only deduction to take is the 1 1/4. So that gives us 116 and 0.5625, which is 9/16. Okay. So 116 and 9/16 inches. So we can confirm that by going into our BIM model and highlighting. You can highlight on this side view. So 116 and 9/16. Okay. So with that, we have confirmed the correct parts are being shooted out for the BIM model, and also the correct cut sizes for these parts. Okay, so with that knowledge now, I want you to apply it to the remaining units that we already created out from the Revit. So 4 more. I want you to check if the correct parts are there, the correct size, and more importantly, the right quantity too. Okay, so I'm going to pause the video here, and it will come back, and then we can back check each other's units, and you can confirm whether your sizes are correct, whether your quantities are correct, and whatnot. Okay, so I'll see you guys in a bit.